Question 3, Part A. In the diagram, A, B and C are the points 10, 5, 12, 16 and 2, 11 respectively. Copy or trace this diagram into your writing booklet. Part 1. Find the distance AC. We can use the 2-point distance formula to find the distance between point A with coordinates 10, 5 and point C with coordinates 2, 11. So using the 2-point distance formula, we have AC squared is equal to 10 minus 2 in brackets squared plus 5 minus 11 in brackets squared. In other words, AC squared is equal to the difference in the x coordinates squared plus the difference in the y coordinates squared. So evaluating the right-hand side, we get AC squared is equal to 100. Now, because AC is the hypotenuse of a right-angled triangle that's formed around points A and C, we need to take the square root of 100 to find the length of AC. So taking the square root of 100, we get AC is equal to 10 units. Part 2. Find the midpoint of AC. The coordinates of the midpoint of AC is found by averaging the x and y coordinates of points A and C separately. So the x coordinate of the midpoint of AC is found by x equals 10 plus 2 in brackets divided by 2, which equals 6. So that's the average of the x coordinates 10 and 2. And the y coordinate of the midpoint of AC is found by y equals 5 plus 11 in brackets divided by 2, which gives us 8. So that's the average of the y coordinates 5 and 11. Putting that together, we get the coordinates of the midpoint of AC are 6, 8. Part 3. Show that OB is perpendicular to AC. Two lines are perpendicular, in other words, right angles to one another, if the product of their gradients equals -1. So the gradient of OB is found using the 2-point gradient formula. So that's y2 minus y1 in brackets divided by x2 minus x1 in brackets. So that's the change in y divided by the change in x. So 16 minus 0 in brackets divided by 12 minus 0 in brackets is equal to 4/3 as a fraction. Now the gradient of interval AC, found in a similar way, is 5 minus 11 in brackets divided by 10 minus 2 in brackets, which gives us -3/4 as a fraction. So multiplying these two gradients together, 4/3 times -3/4 gives us -1. Therefore, OB is perpendicular to AC. Part 4. Find the midpoint of OB and hence explain why OABC is a rhombus. The x-coordinate of the midpoint of OB is found by averaging the x-coordinates of point O and point B. So 12 plus 0 in brackets divided by 2 equals 6. Now in a similar way, the y-coordinate of the midpoint of OB is found by averaging the y-coordinates of point O and point B. So 16 plus 0 in brackets divided by 2 equals 8. Hence the midpoint of OB has coordinates 6, 8. Now the midpoint of OB coincides with the midpoint of AC, and OB is perpendicular to AC, which we proved in part 3. Hence, the diagonals AC and OB of quadrilateral OABC bisect each other at right angles. That means the two diagonals cut each other in half and they meet at 90 degrees. Therefore, OABC is a rhombus. Part 5. Hence or otherwise, find the area of OABC. To find the area of a rhombus, we halve the product of the diagonals. Now in rhombus OABC, we know the length of diagonal AC, which is 10 units, and we found that in part 1. We need the length of diagonal OB, however. Now O represents the origin, and B represents point B, which has coordinates 12, 16. And because we're finding the distance from the origin, we can use Pythagoras' theorem to find the length of OB. So OB squared is equal to 12 squared plus 16 squared. So we have OB squared is equal to 400. Taking the square root of 400, we get OB is equal to 20. So the area of rhombus OABC is equal to half times OB times AC, which equals half times 20 times 10, which equals 100 square units.